You've just set sail on the SS Imagination.
What do car crashes, roller coasters, and hurricanes have in common? They're really scary and potentially life-threatening? Wrong. They're all examples of a phenomenon called fictitious forces. Forces are a push or pull that cause an object to move and accelerate, which means it changes its speed or direction, also known as velocity. Acceleration can look like an object speeding up, slowing down, or turning. Sir Isaac Newton defined 3 laws of motion. 1. An object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an external force. This explains a concept named inertia. 2. The magnitude of a force is the mass of the object times acceleration. The direction of a force is not always the direction of an object's motion. 3. Every force has an equal and opposite reaction force. Fictitious forces are non-interacting, as in not a result of interacting objects. Instead, they are effects on an object's motion that are observed in non-inertial frames. An inertial frame is one where the observer is in constant velocity or at rest. A non-inertial frame is one where the observer is accelerating. When observing an accelerating object, the sum of the forces would add up to the mass of the object times its acceleration. However, if you are observing through the object itself, the net force experienced must theoretically add up to 0, but is not always the case. The fictitious force is created to explain this inconsistency. They keep Newton's second law of motion true in non-inertial frames, and you can even perform calculations with them. Let's start with our first example. Imagine you are in a moving car at a constant velocity, thus in an inertial frame. Then the car suddenly brakes. You are no longer in an inertial frame. You start to feel like a force is pushing you forward, creating the need for seatbelts. That is a fictitious force. It's not a real force pushing you, just an effect observed by your body's inertia. Next is the centrifugal force. In circular motion, the centripetal force causes an object to move in a circle, pointing in the direction of the center of the path. When you're on a roller coaster loop, you feel like you are being pushed against the tracks. That is a centrifugal force. Another good example for this is a centrifuge, which is a machine that spins around a substance to separate its particles by density. Now onto the Coriolis force. In a rotating frame of motion, an object that is traveling in a straight line will appear to curve. This effect is used to explain the motion of wind currents. Because the Earth is rotating, it is a non-inertial frame. The Coriolis force can explain why wind currents in the southern hemisphere move in a clockwise direction, while those in the northern hemisphere move counterclockwise. As a last fun fact before we end this video, in Albert Einstein's general theory of relativity, he claims that the gravitational force is also a fictitious force, but that deserves its own video. Fictitious forces enable us to understand the world around us when certain other explanations don't make sense, filling in the blanks of traditional mechanics. Fictitious forces are not fictional, they are very useful and very real.